Okay, so to teach you how to do this, we're going to start with number 7, and you'll see why in a second. So it says, state if the given binomial is a factor of the given polynomial. What does that mean? How do we know if x minus 2 is a factor of this cubic equation? We do the box, we divide it, and we get, if it has no remainder, then it goes in evenly. If it has a remainder, then it's not. So let's try it. X minus 2 well, it's k, whatever. K is x's, it's all the same. Don't try that on the test, though, because I hold you to a different standard than I hold myself. So k squared, this would be negative 2k squared. Add a column. Negative 2 plus what is negative 1? 1k squared, so just k squared. And this would be plus k, and this would be negative 2k. And then negative 2k plus what is negative k? K again. So k, so this would be plus 1, and this would be negative 2. Does this have a remainder? No, the remainder is 0 because 2 plus the remainder box equals negative 2, and this goes in evenly. So k minus 2 is a factor. What can you tell me about the graph k to the third minus k squared minus k minus 2? It's a function. Do I know anything about its structure or its position? Not what it crosses the y-axis at negative 2, so that is true. Do we know anything about where it crosses the x-axis? Well, if k minus 2 is a factor, then 2 must be a root. Do we know negative 2 at the moment? No, we're left with k squared plus k plus 1. So the other two roots are hidden inside there somewhere. Can you think of two numbers that multiply to be 1 and add to be 1? No. So it's either imaginary or it's irrational. So it probably is something like, let's see, it's a positive k squared, something like this. Two numbers that, if I move that over a little bit, two numbers that multiply to be 1 and add to be, I don't know. I'm just guessing. So, but the important thing is, because this number equaled that number, the remainder is 0. If the remainder is 0, then that factor is part of the original equation, which means that the corresponding root is also part of the original equation. Now, what happens if I come down and I get to this number, and let's say it's 5? How much do I need to get to negative 2? We need to subtract 7 more, so the answer would be k squared plus k plus 1 plus negative 7 over k minus 2. And that's true. That would be the equation, but I never explained to you what is the significance of negative 7. How does it relate to the graph? Why is it negative 7 and not some other number? And the answer is, if you look at the factor that you're dividing, so I'm looking at k minus 2. So if I set that equal to 0, I get the root k equals 2. Now, if k minus 2 is a factor and I plug in 2, I should get 0, right? If you plug a root into the polynomial, you're going to get 0 because it's 2 comma 0. So if you plug in your x equals 2, you'll get y equals 0. Well, what if 2 is not a root? If 2 is not a root, and you plug it in, 2 comma, guess what you get in the y spot? The remainder would be negative 7. So the significance of the remainder is, that is the y value of the root that's not really a root. Does that make sense? If it is a root, then you're not going to have a remainder. So if you plug in a number that's not a root, the remainder tells you how far off the x-axis you are, also known as the y-coordinate of any point. Okay? So that you can always use the division box to divide polynomials, but there's a much faster way to divide polynomials if you're dealing with a single root. Okay? So yesterday we divided it, we had a big polynomial divided by x squared plus x minus 3. That won't work today. Also, if you do something like x squared minus 2, x squared minus 2 is a binomial, but any x squared has 2 roots, and you can't test 2 roots at the same time. So we're going to do something called synthetic division. It's way fast. It's much easier than what you've learned in the past, but I taught you the hard way first because it always works. Synthetic division only works if you have something like this. Okay? So look at number 8. Here's how synthetic division works. Instead of dealing with the factor, we deal with the root. So we set this equal to 0, and we get b equals 7. Okay? So for synthetic division, we write the number 7, and we kind of put it off in its own little box. And then next to that box, we list all of the coefficients of the polynomial that's in the numerator. So the coefficients are 1 from here, -8, -1, 62, and -34. And you have to check to see if you skipped any terms. Do we have any 0 terms in this polynomial? No, if you look at the exponents, 4, 3, 2, 1, 0. So we're good. Okay? And now you leave a little bit of a space and you draw a line. Okay, and then this is quick and easy, and it does essentially the same thing that we've been doing the last couple days. So the first step is you drop down the leading coefficient, 1. And then we're just going to multiply and add all the way across. So we take the 7 from the box and we multiply by 1, and we write it here. And then we just add -8 and 7 equals -1. Now, 7 times -1 is -7. Now we add, what is -1 minus 7? -8. 7 times -8 is -56. So 62 minus 56 is positive 6. And then 7 times 6 is 42. And then -34 plus 42 is 8. And this last box is the remainder. So, does b minus 7 divide in evenly? No, it has a remainder of 8. So the question asks, state if the given binomial is a factor of the polynomial. No. Okay? But what is the answer? So these represent the coefficients of the new polynomial. So what would the new polynomial be? yb to the third. Anytime you take b to the fourth and you divide it by b, you're going to lose 1 degree. So the new polynomial, notice, has 1 fewer coefficient than the original polynomial. So it's going to be b to the third, or 1b to the third, minus b squared, minus 8b plus 6 plus 8 over b minus 7. That was super easy, right? Okay, now, you have to be careful with synthetic division. It only works if you have a linear binomial in the denominator. That's the only time this works. Okay? And you have to make sure you check for 0 terms. If you miss the 0 terms, you foul everything up. Okay? So, because we're not using any of the b's in all this calculation, it's really easy to make a mistake and skip over one and forget that you had it. which in the box, you have to have everything lined up or it won't work. So now we can go back to number 1, and it says, evaluate the function at each value. So I could take 2 and stick it in there, and stick it in there, and calculate it. But I want you to do this using division. The long way to do it would be to turn this into a factor, x minus 2, and do the box. Okay, and then what will your answer be? What are we looking for? When I solve this all the way out, how do I know what the answer is? We're looking for the remainder, right? The question is saying, for this function, 2 comma what? That's what we're looking for. So you could use the box, and you get down, you fill out that column, and you fill out this column, and your remainder is the answer. But we can use synthetic division to do the same thing much, much quicker. So what do I put up here in the corner? The number in the corner is the root we're checking. So 2. If it's a factor, you have to change its sign. So we put a 2 here. And then, what are my coefficients? -1, 0, 6, and -7. So that's one of the downsides of using synthetic division. Is if you don't notice that we skipped a term, you're going to mess things up. And you could actually solve the whole problem and never realize you made a mistake, because we don't care what the end equation is. All we're looking at is the remainder. So then you draw a line, drop down the first coefficient, -1, and then just multiply and add until you reach the end. So 2 times -1 is -2. 0 minus 2 is -2. 2 times -2 is -4. 6 minus 4 is 2. 2 times 2 is 4. -7 plus 4 gives a remainder of -3. So the answer is f of 2 equals -3. When I plug 2 into the function, I get out -3, or you could write 2 -3 like that. And the resulting equation would be -x squared minus 2x plus 2 minus 3 over what? 3 over x minus 2. Because the factor associated with x equals 2 is x minus 2. But none of that matters in this top part. All we care about is that answer. So if you have a big, long polynomial and you don't have a calculator, it's pretty easy to do synthetic division to figure out what it equals. Which is strange, right? I mean, if I plug 2 in there, -2 to the third plus 6 times 2 minus 7. So that's 2 to the third is 8. -8 plus 12 minus 7 happens to equal -3. That's really bizarre, isn't it? That same calculation can be done these two different ways. So we won't get into why that's the case. All right. Let's do number 6 together. So we're evaluating the function at x equals 7. Now, you could plug 7 into all those x's in your calculator and hit enter, or you can use synthetic division. So 7 goes in the box. What are my coefficients? 1, 0, -47, -16, 8, and 52. So I drop the first coefficient, I get 1. 7 times 1 is 7, so that's 7. 7 times 7 is 49, so this is 2. 14, -2, -14, and -6, minus 42, so my answer is 10. So that did not go in evenly, so 7 is not a root. If you plug 7 into the function, you end up with 10. Okay? So I think that'll take you all the way to the end. Maybe we'll do, did we do 8? Yes? Okay, let's do 9, just to remind you of one more thing. So this does not want to know the value. This wants to know when you divide them, what do you get? So what do we put in the box? Well, first of all, how come I can use synthetic division? Because this is a linear binomial. If I solve n plus 8, I get the root -8. If it was something like n squared minus 16, I can't test that because the roots are actually plus or minus 4. So I would have to test 4 and see if it works, and then I'd have to test -4 to see if that works. So you can only test one number at a time. All right, what goes in the box? -8, because that is the root associated with n plus 8. So my coefficients, am I missing any? Nope. So 1, 9, 14, 50, and 9. Drop the 1. -8 times 1 is -8, which is 1. -8, which is 6. -8 times 6 is -48, which is 2. -8 times 2 is -16, which gives me a remainder of -7. Did I do that right? So what is the answer? Well, I started with an n to the 4th, and I divided it by n, so I'm down 1 degree. N to the 3rd plus n squared plus 6n plus 2 plus -7 over the divisor n plus 8. So don't forget how to divide using the box, because it always works, regardless of what you're dividing by. But if you're dividing by a linear binomial, then go ahead and use synthetic division. It's much quicker. Okay? Good luck.